Alright, in this video we're going to be looking at the quiz that covers lessons 4.1 to 4.5, which is pretty much everything that you're going to be taking your test on coming up. So you want to make sure that you know what to do for these problems. Alright, so let's start with this first one. So this first one gives us the values for sine and cosine. So the sine of theta is negative 0.966 and the cosine of theta is negative 0.259. Now I am not going to give you any value, very many if any, on the test where you have to just find the sine of a value, because I can't supervise you. In the past, we've had students do these without a calculator. So this would be something this would be the type of question I would ask, where you have to make sure that you know how to use those different properties. So this particular property where we have the sine of 180 minus theta, this is the Supplements Theorem. So the sine of 180 minus theta is equivalent to the sine of theta. So we know the sine of theta is 0.966, so my answer for this would just be negative 0.966, and you could put negative 0.0966, or without the zero, it'd be the same answer. So again, you would get that from your notes, making sure you know these different theorems. So this one, it says, suppose sine of theta is 0.139. In the first quadrant, find the cosine of theta. And the reason why this portion is in here, talking about the first quadrant. Remember, in the first quadrant, everything's positive. So when we get our answer, technically we would have two solutions, a positive and a negative, because we're going to have to use the Pythagorean identity theorem. We're going to have to use that to be able to find this value for cosine. And when you do it, you're going to end up getting two solutions, a positive and a negative. But since we're dealing with the first quadrant, all I care about is the positive value. So how do we use that? Well, remember the theorem, the Pythagorean identity theorem, says that the cosine squared theta plus the sine squared theta equals 1. So remember, we use this formula anytime they give us the sine and we need to find the opposite, the cosine. Or if I'd given you the cosine and we need to find the sine, that tells us that we have to use this Pythagorean identity theorem. Alright, so I know the sine of theta is 0.139. So all I have to do is plug that in and solve it. So what I'm going to do is I'm going to subtract 0.139 squared from both sides. And so you could do this all in one step. And so you don't have to do this in multiple steps. You can just do this all in one. So I would take 1 minus 0.139 squared. And when I do that on the calculator, I get 0.980679. Now, even though it says around your answer, it says around your final answer, the nearest thousandth, we want to make sure that as we're working through this, we're not rounding too close to decimal. So I'm just going to leave this as 9.8068 just to be safe. All right, so now to find theta, I would take the square root of both sides. And technically, this is where we'd have two solutions. We'd have a positive and a negative value. But again, since I only worry about it being in the first quadrant, the cosine would be positive. So when I do this, I get 0.990 as my answer when we round to the nearest thousandth. So if you just said 0.99, I would give you full credit for that, but technically it'd be 0.990. And after the 0 is a 2, so that's why we don't round it up to a 1. All right, so this one, it says convert 5/6 of a counterclockwise revolution to degree. Now remember, if it's a counterclockwise revolution, that means it's going to be a positive revolution, and one revolution is 360 degrees. So we're going to take 5/6 of 360, which if you do that, you end up getting 300 degrees. So your answer is just 300 because the degree symbol is already included. All right, so this one is another one of these where I give you the two values. So we need to use those different theorems. So the sine of 90 minus theta, this is the Complements Theorem. So the other one we learned about or talked about just a little bit ago was the Supplements Theorem. So this one is dealing with the Complements Theorem. So the Complements Theorem tells us that the sine of 90 minus theta is equal to the cosine of theta. So the cosine of theta is negative 0.259. So that's going to be our answer here, negative 0.259. Okay, so for this one, we're going to convert 8 pi over 3, so that's in radians. We're going to convert that to degrees. So to convert that to degrees, we're going to multiply that by 180 over pi. So when you do that, the pi's cancel out. You can also even take this one step further. 3 goes into 180 60 times. And now 8 times 60 would be 480 degrees. So our answer for this 8 pi over 3 radians is the same as 480 degrees. All right, so this one we're going to convert 280 degrees to radians. We want to use the exact value, so no credit for a decimal. Okay, so I want you to do this by hand. So we're going to convert this to radians. So we're just going to multiply by pi over 180, so that would give us 280 pi over 180. Now we want to, anytime we work with fractions, we always want to reduce. So I notice that 10 goes into those, so now I'd have 28 over 18. But then I also recognize that this can still be reduced further. 2 goes into both of those evenly. So 2 goes into 28 14 times and 18 9 times. That can't be reduced any further. Now we've already got the pi in here, so 14 pi over 9 is the same as 14 over 9 pi. Those two are equivalent. So all we have to do is just type in 14 divided by 9. All right, number 7. So this one, again, they give us the two values here for the sine of theta and cosine of theta. So we have to find the sine of the opposite of theta. So this one makes sense. Find the sine of opposite theta. That's the opposites theorem. So the sine of the opposite of theta is equal to the opposite of the sine of theta. So sine of theta is negative 0.966. So the opposite of this would be a positive 0.966. And remember, the tangent of theta is a sine divided by the cosine. It's a sine of theta divided by the cosine of theta. So the sine of theta is negative 0.966. The cosine of theta is negative 0.259. So my answer here is going to end up being a positive value because a negative divided by a negative would be positive. And my answer would be 3.7297, but we're going to round to the nearest thousandths. So this would be 3.730. If you said 3.729, I gave you credit. Technically, though, we'd want to round that up to 3.730. Or if you just said 3.73, that would be fine as well. All right, so for this one, we had to determine whether or not this represents the sine function or the cosine function. And the way that we can tell is the x-intercepts. So 89 pi over 2, 91 pi over 2, 93 pi over 2. Those are odd because 9, 1, and 3 are odd numbers. Those are odd multiples of pi over 2. So that tells me it is the cosine function. And all of these are true, but the only one of these that would determine the fact that this is the graph, or this is the cosine function, is the second one. Its graph has zeros at multiples of pi over 2. Because just saying it's a sine wave, both the sine and cosine graphs are sine waves. Just saying it repeats itself every 2 pi and has a range from negative 1 to 1, that's the same for both sine and cosine function. Its graph has zeros at multiples of pi, well, that would be the sine function. So the only one that would make this specifically true for this exact graph, for us to be able to tell that this is the cosine function, is the fact that its graph has zeros at odd multiples of pi over 2. All right, so this one, it says convert 7/9 to clockwise revolutions to degrees. Now the fact that it's clockwise means that it's going to go in the negative direction. So we would multiply that times negative 360. Well, 9 goes into negative 360, negative 40 times 7 is negative 280 degrees. So your answer here would be a negative 280. You do not get any points for saying positive because part of this deal is making sure that you recognize that a clockwise revolution is going to be a negative direction. So if you said positive 280, you did not get any credit for that. All right, number 11 says find the cosine of 180 plus theta. So again, this is using those different theorems. And so this is the half-turn theorem, which states that if we have the cosine of 180 plus theta, if we rotate halfway around the circle, it's going to be the opposite of where it started. So it's going to be the opposite of the cosine of theta. So the cosine of theta is negative 0.259, so the opposite of that would be a positive 0.259. And lastly, we have the story problem. And I did a little research, and the Wheel of Fortune, the actual wheel, on the Wheel of Fortune is about 6 feet in diameter, which means its radius is about 3 feet, or 36 inches. If a contestant spins the wheel and it makes 8.5 revolutions, how many inches does the wheel travel from its starting point? So remember our formula for the arc length, because that's what we're dealing with. We're dealing with how far of an arc this has traveled. We take the radius times the value in radians. Okay, so this would be in radians. So theta here would be in radians. Well, they don't give us how many radians the wheel has gone around. It tells us that it's gone 8.5 revolutions. So 1 revolution would be 2 pi radians, and so we want to figure out how many radians 8.5 revolutions would be. So we would multiply that times 2 pi. And then we would take the radius, and let's go ahead and throw that in there. So the radius would be 36. So what I'm going to do is I'm going to take 36 times 2 pi times 8.5. Now technically you do want to use pi instead of 3.14. But if we use pi and we round to the nearest inch, we get 1,923 inches. Now if you had said, instead of pi, if you had said times 3.14, your answer would be 1,922 inches. Okay, so just an inch off. It's not quite as accurate if we use 3.14. But 1,923 inches would be the best answer there. All right, so that's how you do the quiz. So hopefully that answers the questions you got wrong. You want to make sure that you know how to do all these problems because you'll see similar problems on your test. So if you do have questions, please make sure that you reach out to me so I can help you out.